The aerospace industry is currently undergoing a massive structural transformation. As commercial air taxi firms look to survive the so-called Valley of Death, they are pivoting toward defense-related mergers and acquisitions, all while global regulators increase restrictions on airspace. Commercial air taxi companies are burning cash while awaiting certification. To survive, giants like Archer and Joby are acquiring defense tech. Meanwhile, in Japan, a strict 1-kilometer lockdown zone has been implemented, forcing new specialized hardware and software standards. Archer is leading this consolidation trend. By acquiring Whisk Aero, SkyGrid, and In-Situ, they are gaining critical R&D assets, air traffic management software, and established military drone manufacturing capabilities, all with continued backing from Boeing. The acquisition of In-Situ serves as a financial lifeline for Archer. With over $200 million in annual defense revenue, thousands of drones deployed, and vast amounts of operational flight data, this move has significantly impacted Archer's market value. Archer is also scaling its military ecosystem through partnerships. This includes collaborating with Anduril on hybrid electric platforms and working with Korean Air to introduce a militarized variant of their Midnight vehicle-to-defense programs. Joby is pursuing its own strategy, investing $500 million to acquire Resonant Sciences. This gives Joby essential defense capabilities in radio frequency sensing, signal processing, and stealth technology, further solidifying its pivot into the defense sector. As companies move into the final stages of FAA certification, they face immense cash burn. Projections for the latter half of 2026 show critical levels of spending, highlighting why a shift toward high-margin defense revenue is vital for long-term sustainability. Beta Technologies is taking a different approach by focusing on infrastructure. They have secured a $1 billion letter of interest for manufacturing and expansion, leveraging their extensive network of charging nodes and flight data to avoid excessive shareholder dilution. Commercialization efforts vary globally. EHang has successfully achieved autonomous flight in Kazakhstan, while in Japan, companies like SkyDrive are aggressively pursuing social implementation in locations like the Osaka Port Vertiport, with significant funding. Regulatory lockdowns are forcing hardware fragmentation. Regulations now categorize drones into classes C0, C1, and C2, with each class facing different restrictions on weight, operator certification, and required separation distances. Manufacturers are engineering products to meet these strict compliance standards. DJI, for instance, has tailored its lineup, with specific models engineered to stay under weight limits or designed to meet the technical requirements of different regulatory zones. Software is also being updated to ensure compliance with physical realities. New firmware for agricultural drones now includes automated low-speed algorithms to prevent damage to crops from rotor downwash, demonstrating a new focus on precision and safety. In Japan, airspace regulations have tightened significantly. A new amendment to the Drone Act has expanded buffer zones around critical facilities to a 1,000-meter yellow zone, requiring strict notification and consent for any operation. Enforcement has shifted to a zero-tolerance policy. Entry into restricted zones can now result in immediate criminal penalties. Additionally, pilot licensing is more rigorous, emphasizing critical safety judgments, including the decision not to fly.
Lessons from the August 2026 European solar eclipse highlight critical physical limits for drone sensors. Standard ND filters failed to block radiation, leading to permanent hardware damage. Furthermore, at specific low angles, solar exposure created catastrophic fatal loads on drone optics. Scaling megashows presents ongoing challenges. While fleets of 3,000 drones have been achieved, meteorological realities remain a significant bottleneck. Abrupt cancellations due to sudden wind and rain highlight the vulnerability of dense swarm control and attitude correction systems to volatile weather conditions. SoftBank and Sceye are initiating the next phase of 3D communication infrastructure. Following a strategic investment, pre-commercial tests are underway over Japan, with full commercialization targeted for 2027. This effort utilizes helium-based, lighter-than-air platforms designed for extended stratospheric loitering. Global remote operations are advancing through trans-Pacific deployment. Craft launch from Roswell and are tracked across the ocean using custom algorithms and ground-based antennas. The Kochi Ground Gateway provides the essential connection to stable power and high-speed fiber optics to maintain this infrastructure. 3 core verifications are proving commercial viability in the stratosphere. These include precise station keeping against jet streams, direct data communication with standard smartphones, and the seamless handover of users between terrestrial towers and stratospheric networks. Sceye technology provides ultra-wide coverage, where one stratospheric platform can equal the capacity of 500 ground towers. This architecture offers vital disaster resilience, ensuring immediate emergency communications and continuous connectivity for autonomous drones, even if physical infrastructure is destroyed. When comparing LEO satellites and HAPS, each serves distinct roles. While LEO constellations fill broadband gaps in remote regions, HAPS platforms operate at only 20 kilometers altitude. Being significantly closer to Earth allows HAPS to provide superior uplink speeds essential for real-time drone telemetry. We are seeing a convergence of the 3D ecosystem, marking the end of standalone hardware. Aerospace giants are integrating defense and navigation systems, as hardware alone cannot navigate congested airspace. Seamless integration between ground and stratospheric networks is now mandatory for safe beyond visual line-of-sight flight. HAPS serves as an essential enabler for 6G, securing the future of aerial mobility. By eliminating communication blackouts for drones and eVTOLs, this multi-layered infrastructure provides the total vertical data integration required to guarantee operational safety in next-generation urban transit. The future outlook suggests a compliance-driven oligopoly. As regulators crack down on operations, the market will favor system integrators who can bundle stratospheric communications, ground-based traffic management, and legal compliance into a single, unified service for the 3D economy.